Okay. So I guess everyone looking at this video trying to know how to solve the second x integral. Okay. So in this video, I provide two methods. So let's don't waste you guys' time. Let's start. Hope you guys subscribe to my channel. So the first one is a genius idea. Okay. So the genius ideas means that you are so genius, so you know that I can write the second times second plus tangent. Okay, and and I get this. So I just expand it out. Okay, and the one common sense in the trigonometry is that the second differentiation is second 10, and the tangent differentiation is the second square. Okay, so that means this guy is a tangent differentiation, this guy is a second differentiation. Okay, so genius idea will give you the answer because you see this total sum is just the total sum of this. So it's long second x plus tangent x. Absolute value take a constant. So this is a natural log. Okay. So this is idea called a genius idea. Okay. So next, let's talking about a common idea. Okay, the common one. So common one means that you are not so genius, right? But you still love mathematics, or you still try to do the homework. So okay, so you need to find a way. So okay, what I'm writing about. Okay, so the idea is that you know the second is a 1 over cosine x, right? Dx. So you up to here that you have no way to solve it, right? Because you don't know how to get out with the single cosine. Okay, so idea is that you test times another cosine, right? And then you solve this cosine. You return this cosine square is 1 minus sine square x cosine x dx. Okay, then you know that this cosine x can be written as 1 minus sine x, right? Plus 1 plus sine x. So this product will give you another 2, right? So you need to divide 2. Okay. So from here that you will get a half cosine x dx 1 minus sine x plus cosine x dx 1 plus sine x. Take a half. Then everything will be easy, right? Because this term can be written as a d 1 minus sine x. So sine differentiation is cosine, right? So you need to add the minus sign, and the least term can be written as d 1 plus sine x. Okay, so the first term will be half times a log 1 minus sine x plus half log 1 plus sine x plus constant. Okay, so combine everything, you get log 1 plus sine x divided 1 minus sine x plus constant. Okay, and then what's next, right? So what the next is that you need to try to solve. You need to try to prove. Actually, this is the answer, right? But you need to try to prove. So try to show this is the same as the second plus tangent. So in order to so now we already get an answer, right? But the key is that we need to prove that the first method one, the method 1 and the method 2 should be the same. Okay, so what's next? What's next, right? The next is just keep computing and try to get these things. Okay. Let's see. Okay, so next thing is that I should take a square root, right? So I should take a log. Right, so I can take a square root, and so it's you need to try to prove that this guy is actually this. Okay, so let's see. Okay, so you see this is 1 plus sine, 1 minus sine, and this guy is a second, so it's 1 divided by cosine. So I use c, and the cosine sine divided by cosine, right? So it's a cosine 1 plus sine, cosine and sine cosine, right? So you see here, you get this term, and then you get this term. Okay, so now the key idea is that can you show? I mean, at least you try to prove this. When your sine is part, right? You try to prove this. Okay, and you can easily see why this is correct. Okay, so let's maybe do this. let's see. Okay. So one idea. Okay, so let's see. You get 1 plus minus sign, 1 plus sign, right? So you can times 1 plus sign. So you get this. Okay, and you take, since it's in the square roots, right? So you can take 1 plus sine divided by 1 minus sine squared, right? So 1 minus sine squared, which is cosine. So you get the tangent plus secant, right? So you just it's very easy to show you. So this is just the same as this by just using this. Okay, so hope you guys like this video, and now you can see these two methods give the same answer. Okay, see you guys next videos.